Unit 7, Day 2. Lots of stuff. That's not the official title, of course. So we'll talk about radians and degrees, kind of go back and forth between them. And then we'll do arc length and sector area. Sounds fancy, but we'll be okay. So, Roman numeral 1 of 2. That might be a little misleading, though, because both of them are lengthy. Convert radians to degrees and degrees to radians. So I'll just show that with an arrow going both directions. We'll give you one and ask for the other, and then give you the other and ask for the whatever, either way. But probably the first thing we should think about, and make sure we understand what radians and degrees are. They're both ways to measure. You know what? Ways is kind of a not clear term. Units to measure an angle. Units to measure an angle. And you're pretty familiar with degrees, right? Like, what's all the way around in degrees? If you do a full spin, how many degrees is that? 360. What about a right angle? What's a right angle in degrees? 90. How about a flat line? What's the angle? 180. So you're pretty familiar with degrees. If I ask you to sketch a 45-degree angle, most of you would probably be right within 3 or 4 degrees, even without a protractor or anything, because you just kind of got a good feel for what degrees are. You don't have such a good feel for what radians are yet, and that's okay because we're just learning them. But that's going to be part of today, is starting to get a feel for radians. It's a little bit analogous to feet and meters, right? They both measure length, but when you're in physics, like, you got a good feel for feet, like you know how far 10 feet is, how tall 6 feet is. But then when you switch to meters, it's like, how big is 4 meters? How big is half a meter? Like, your first time through, you don't know. After you've been in physics a while, you've seen enough meter sticks to be able to kind of figure it out. And hopefully the same thing happens with radians and degrees. It's hard initially. It never gets as easy as degrees probably, but the more we do, the more comfortable you'll feel with it. All right, we already said the full circle, like going all the way around a circle, is 360 degrees. That's what you know. If there's any skateboarders in here, you know the 720, you know the multiples of 360 because those are the tricks, right? Two full revolutions is a 720. 3 is a 1080. In fact, isn't there a video game named 1080? Am I wrong on that? I think there used to be, maybe, before your time. Skateboarding video game. So, again, you're kind of familiar with degrees. Does anybody know how far it is around in radians? A full revolution in radians?
I think like 32.
It's not 32. It's very much related to the circumference.
Yeah.
What's the formula for circumference?
Pi r squared. No.
Area is pi r squared.
Yeah.
So you're in the ballpark.
2 pi r.
2 pi r. And 2 pi is how many radians there are in a full rotation or a full revolution. So you're like, it wasn't really close. But. So that's maybe how some people remember it. When you want to convert, you could reduce that a little bit and say that pi is equal to 180. And that's probably the conversion factor that we'll use. Just like there's 3 feet and a yard are the same thing, 12 inches and a foot represent the same thing, 180 degrees, pi radians represents the same thing. All right, let's change degrees to radians. And I always get groans at this point because we're going to do something from chemistry. And in my mind, it was the easiest part of chemistry because you didn't have to understand the chemistry to do this part of chemistry. And so to a math person, apologies to our chemistry teachers or chemistry people if you like it, like I never felt like I understood the chemistry. Like I could do the math, I couldn't really understand what was going on. That's definitely true with the train track thing. Do you remember that from chemistry? I guess so, from the but even if you don't understand liters and moles and atmospheres and all that stuff, you could at least make the units work out. And that's what we're going to do today. And so you don't have to, the good news is you don't even have to know any chemistry today. You just have to make the units work out. So if there's degrees in the top and I want to change it to radians, so I want degrees to go away, I better have degrees in the bottom. And if you want to write it out because it's easier to mark out degree rather than the little circle, that's fine. But what's 180 degrees the same thing as? Pi radians. So here's, I think, what we miss in chemistry is we don't emphasize enough that you're multiplying by 1. It doesn't look like you're multiplying by 1. But if pi radians and 180 degrees is the same thing, then you're not changing the value of 60 degrees. I mean, you're going to change the number, but you're multiplying by 1. So whatever 60 degrees is, we're going to change that to radians, but it's still going to be the same opening. It's just going to be a different number. Let's see. The degrees cancel. We've made that happen. We're only left with radians. That's what we want. And then 60 over 180 was 1/3. So I'm going to just write that as pi over 3 radians. And maybe I should have shown an extra step in there. 60 pi over 180 is pi over 3. So there's a little bit of reducing, but most of them are sort of rigged to reduce kind of nicely. Usually don't have anything too weird. Let's convert negative 140 degrees to radians.
That's not going to be as nice.
What's that?
That's not going to be as nice.
That's not going to be as nice, you're right. The process is the same though, right? There's degree in the top. I want degrees to go away, so I put degrees in the bottom, which means the radians goes in top. So yeah, you're right. It's not as nice, but it's not awful. What could divide into both of those? 20. If you don't like 20, you can start with 10 and then do 2 after that. Haven, what's up?
So is it always going to be like 180 in the bottom?
Well, yes, when we're doing degrees to radians.
Okay, and then like...
We'll do radians to degrees in a minute, and that'll flip things around. Okay, so divide by 20 works. What I saw first is divide by 10. And then divide by 2, which means, yes, dividing by 20 would have been the smarter, quicker way to go. But maybe not everybody saw that right away. Again, show as many steps as you need to in there, on your road to reducing. A little side note, on the test, every year there's somebody who forgets the negative. So they do all the hard part right, but they leave off the negative of their answer. It's frustrating, right? It's only a point, but if you end up with an 89 instead of a 90 because you just forgot to include the negative, that's frustrating. All right, let's go the other direction. Radians to degrees. Do you flip everything? Kinda. Let's do 3 pi over 4 radians. And probably the best thing to do is just sort of extend the fraction bar. Otherwise, you got fractions and things start to look a little weird. So just sort of extend the fraction bar. Now we want radians to go away. So what should go in the bottom to cancel the radians? Right, pi radians. And what's the same thing as pi radians? 180 degrees. Now, again, don't memorize, well, if we're going radians degrees, then pi goes in the bottom, but if we're going degrees to radians, pi goes in the... Don't think of it that way. Think of it as, what do I need to do to make the units work out? If I want the radians to go away, then put radians in the bottom. That's an easier thing to remember than remembering, who's in top, who's in bottom, all that stuff. All right, radians go away. Oh, what else goes away? The pi goes away. So that's kind of nice. 3/4 of 180. Let's see. What do I want to do first? 3 times 180 or 180 over 4? I think 180 over 4 is the right. I mean, either one would be correct, but the easier grouping, I think, is 180 divided by 4. Would be 45. Divide by 2, you get 90. Divide by 2 again, you get 45. I'm looking ahead. Some of this is no calculator, some is with calculator. This is on the no calculator part. 45 times 3, either out to the side or kind of add them up or however you want to get there. 135. Degrees. Don't forget the symbol for degrees. That was the whole point. To convert it. Yes, definitely on this one. Now, if you could argue it if I said find the angle in degrees, and so if the question includes degrees and you answer 135, then you could argue, well, you asked me how many degrees, I answered your question. Maybe, but for this, when we're converting, I would definitely want to see the degrees. This is probably a multiple choice, and I'm looking at the worksheet today, and all of them have a degree marker on there. It's not like you're going to have one choice that's 135 and another choice that's 135 degrees. Like, that would be cruel.
Yeah.
Humorous, maybe, but cruel.
Or that should be like the whole Testament where we all know.
That's right. Why don't you try this one? Negative pi over 10 radians. Convert that to degrees. Let's see, the pi, this one's really easy. The pi's go away. 180 divided by 10 is 18. 18 degrees. What do you think of my answer?
It needs a negative.
It needs a negative. Again, that's the easiest part, but sometimes, every year there's one or two people who miss one of those because they just leave the sign off. All right, so that's better than the chemistry train tracks, right?
Yes.
Yes.
I think because chemistry train tracks usually end up with like 8 train tracks, and you've got to cancel the liters and the ATMs and the moles and the kilograms and the grams and the yeah. Here it's just one, so a little easier.
Realize that's not the answers.
Coterminal angles.
Hold up.
Coterminal.
Yeah.
This isn't an maybe it sounds but especially if we think,
Why are they terminal?
what does terminal mean?
It means there's an end.
It means there's an end. That's exactly right.
Yeah.
Right? I mean, not to get, well, we can get not morbid first and say the airport terminal is where your flight ends.
Oh, okay.
But
It's
if
also working star.
it's also work, yes, that still kind of works on this. The morbid part is if you have a terminal disease, that means the end is coming. I mean, that's not a fun one to think about,
So
but
if you go to the airport, so if it's coterminal,
what's co mean?
you have partner to
Both.
somebody. Yeah.
Both or same.
They're all ending.
So we're going to have angles that end at the same place. So let's see if we can come up with an example of. We always start at the positive x-axis. So if I rotate 90 degrees, that would be an angle. A coterminal angle would be another angle that ends at the same spot, with the same ending. And maybe you don't see a different way to get there, but if we went backwards.
Why wouldn't it be the box?
Yeah, you could put a box there, that'd be fine. How far backwards would we have to go to land at the same spot? Negative 270. So 90 and negative 270 are coterminal. They have the same ending.
You forgot the degree.
I did. Can you think of another way to get to 90?
3 foot.
It's kind of a creative way to get there. And we kind of mentioned it earlier with skateboarding and
360
spinning.
minus 270.
360 minus 270, that's sort of right. That would get 90 when we already have 90.
How do we get 90?
Can you go from the other side?
Where did 450 come from?
I added 360 and 90.
If we go all the way around, that's 360, and then we go 90 more. So that's another coterminal angle. And that wouldn't be the easiest way to get there, but you still get there. You could go around twice, so 720 plus 90, or 1080 plus 90, or whatever comes after that.
So
14.
So you can add or subtract 360 or 2 pi if you're in radians, because that would represent the same thing, one spin around, as often as you like, or as often as you're required to is maybe a better way to say that, because we can say find 3 coterminal angles or 4 coterminal angles.
So if it's 3 coterminal angles, you just do 360 times 3 plus whatever the angle.
That was 360 times 3 plus the angle would get you one of them. So you'd have to do 360 times 2 plus the angle, 360 times 1 plus the angle. So yes, but that would still only get you, you'd add 360 once, that would get you one answer, add 360 again, that gets you the next answer.
Okay.
You could subtract 360 a bunch of times as well.
Yeah.
This is where I'm glad we switched to doing multiple choice, because this is a spot where every year, like one person per class would get cute on this, and they would say, aha, I know a coterminal angle with 90. It's 36,000 plus 90. Well, yes, it is. Because 360 times 100, this would be 100 spins plus 90 degrees. That wouldn't annoy me so much as if they picked one at random and said, well, you know what, I'm going to spin 537 times and then go 90, and there's my coterminal angle. You're like, it's not wrong.
But you have to.
But now I have to figure out if it's right or not. Now I know how to figure out if it's right or not. Subtract 90, divide by 360. I can figure out if it works. Okay, it works. But I don't want to have to do that. So it's multiple choice, so you can't do that to me this year.
Be a fill in the blank section.
Yeah, if it's fill in the blank, knock yourself out.
Cool.
So let's find 3 coterminal angles let's do one in radians, because that's a little harder because it's fractions. Right? 360 is not a big deal. Especially this one would be with calculator, so not a big deal at all with the calculator.
Can you not just convert it to degrees and then just do it the other way?
And then convert back?
Yeah, can you not just do it?
You could do that. So the question was, can we convert it to degrees, add 360, and then convert back? Yes. That's annoying. Don't do that. Because what do I need to add if I want to get a coterminal with 2 pi over 3? I mean, it's not wrong. I just don't want you to do it that way. What's the equivalent? Let's do it in radians. What's 1 time around in radians? 2 pi. Okay, so we do have to know how to add fractions. I guarantee you one of the free response choices, or one of the multiple choice answers is going to be what? What's the wrong answer going to be?
Pi. Pi squared.
Oh, pi squared. I should ask you guys in order to make the test so I know what wrong answers to put.
Oh.
I would say 4 pi over 3 would be a good wrong answer.
Our jokes are going to mess us up.
I hope,
Yeah, I feel like
hope none of you were thinking that was the answer.
Oh, that's what
It's like, no, wait. If we add fractions, we need a
What's a fraction?
common. What's a fraction? We need a common denominator. So let's add 6 pi over 3. And that would be 8 pi over 3.
And is that one of the coterminal?
That would be one of the coterminal angles. How do we get another coterminal angle?
You add another 6 pi over 3.
Good, and you jumped right to
This is looking like
the common denominator form rather than 2 pi. We already know it's 6 pi over 3, so
And then you just add another 6 pi over 3.
and at some point you're like, wait a minute, I don't even have to write it down.
Yeah, it's just 6 plus 14.
so I don't have to rotate it.
It's 20 pi over 3. What would the next one be?
26.
And then
32.
yeah, and so on.
Here's the question.
So you could write as many as we ask you to.
At that point, it's just adding the number in front of pi.
Yes. Be careful with negatives. Maybe I should have started with negative 2 pi over 3, because then that would have messed some of us up. But it works the same way. Haven?
So, like, how do you know what to add? I'm confused on where you, like, why
You-
you're adding just 2 pi over 3. Like, where is that coming from?
Because that's where we started. We started at 2 pi over 3.
So whatever's like those that you add.
Whatever you're looking to be coterminal with is where you'll start, and then you'll add 2 pi however many times you would like.
And then
Just stick your head in the microwave if you get cancer.
Let's do one more of those. Let's find 2 coterminal angles with negative 100. So lots of potential answers there. But all you got to do is add or subtract 360 if it's degrees, 2 pi if it's radians. Just be careful with the fractions. The fraction thing is really the only thing that messes people up. All right, number 2. Roman numeral 2. Arc length and sector area. Ty? Yep. Arc length and sector area. Arc length is a piece of the circle. So that would be arc length. Let's see, we already said that circumference is 2 pi r. And 2 pi is all the way around. So maybe it makes sense that arc length is whatever that angle is times the radius. Whatever the angle is times the radius. Because if the angle is 2 pi, then you got all the way around and you got circumference. So circumference is sort of a very specific arc length formula. Now we know a formula to find any arc length, as long as theta is in radians.
So if it's in degrees, does that mean you have to convert it?
Correct. Usually you'll know something's up. Like if we ask for the arc length of this, if that's 5, radius 5, and we want the arc length, and let's say you forget, and you're like, oh, that angle's 90 degrees. So 90 times 5 is 450. Like, well, wait a minute. If this is 5, that's not 450, right? Because you weren't supposed to use degrees. You were supposed to use radians. So if you're paying attention and you accidentally use degrees, you'll recognize that something is way off.
How would we have, so if we were given that.
If you're paying attention.
Would we have to convert the 90 into radians?
So you convert 90 into radians and then find the arc length. Yeah. Whoops, that was arc length. Sector area. So it's sort of the same thing. It's the area not of the whole circle, but of a piece of the circle, or part of the circle. Well, let's back up. What's the area of a circle? Like the whole circle.
Jason, you know.
Yeah, Jason said it earlier.
Pi squared.
Pi r squared. Well, the area of a sector, I don't know if this is easier or harder than the arc length. The formula is harder, but the concept, I think, is easier. You start with pi r squared, and you're like, well, but that would be all of it. I don't want all of it. I want some fraction of it.
Over 2.
Well, I don't know that it's over 2.
You gotta find that.
It's theta out of 360.
You gotta find the arc length.
Don't need to find the arc length. I just need that central angle. Or it's pi r squared times theta out of 2 pi if we're in radians. So you can use either one, but it's, I think, clear which one you use, because if you're going to use the 360 one, you use degrees. If you're going to use the 2 pi one, you need to be in radians. So you start by finding the full area, and then you multiply by whatever the fraction is that your area you want to find. Let's do one example. Find arc length and sector area. One example with 2 pieces. Sneaky. Arc length and sector area if r equals 4 inches and the central angle equals 110 degrees. Alright, we didn't say central angle earlier, but you figure out what that means. That's the central angle. Perhaps a picture. Let's see, 110 would be a little more than 90. I mean, your picture doesn't have to be perfect, but might help if it is reasonably close. So arc length is theta times r. Uh-oh. Why am I uh-ohing? What's theta equal to?
In degrees.
110 in degrees. Oh, I snuck 3 problems into this one. If you write 11, it's hard not to automatically make it pi. Or maybe that's just me. 11 pi over 18. Times 4. Because the angle is 11 pi over 18 after we converted it, times 4. I don't need a common denominator because this is a multiplying. I can reduce though. So that's not too bad. 22 pi over 9. Inches. Right? Because sector length would be in inches, not in inches squared.
Wait, why did you? Okay.
So that was all for
That's only one for the
the arc.
column.
That's for the arc length. The area of the sector, pi r squared. I'm more familiar with degrees. I know you're far more familiar with degrees. So I'm just going to do the area times 110 out of 360. That would sort of give me the fraction of the circle that I want. So pi times 4 squared times 110 out of 360. This is probably worthy of a calculator. 16 times 110 divided by 360. Probably doesn't come out nice. But are you familiar with the math frac button? Greatest invention of calculator ever. Maybe not, but close. So that's 44 over 9, but don't forget the pi. And that would be inches squared. So if you're using the calculator, don't stick the pi in there, because if you put pi in there, you'll never be able to go back to math frac. So yeah, that's a decimal answer, but I can't math frac that because pi was in there. So sort of hold pi on your own, let the calculator do all the hard work, and then put the pi back on at the end.
So if it's area, then it's going to be inches squared.
And if it's area, it's going to be inches squared. Yeah. Alright, we finished with like 4 minutes to spare. Olivia?
At the very beginning on the top right, why did you cross out
Up here? Because if you're going to do sector length, you have to be in radians. If you do it in degrees, hopefully you're paying attention. Like if this was 5 inches, and then you're going to tell me that L is 450 inches? Like look at the picture. That doesn't make any sense. The real answer would have been pi over 2 times 5. All right, that was a little bit longer. Tomorrow won't be as bad. Yeah, tomorrow won't be bad at all, really. So try those. Tomorrow's also block day, so we'll have time to work on worksheets, answer questions, and so on.